So in this particular one, we are computing the variables, and we want to make sure that we do a correlation, or rather a regression analysis. And then quickly I'll go to transform, and then I will go to compute the variables, because I want to get the effect of tax assessment on performance. So the best way to do it is to compute these variables under tax assessment, find their average mean, and then run a correlation with the performance, which I also have found a mean. So I will just call it like tax. Don't have to make it long. Maybe let's call it assessment STEAM. So after that, we can move to the first, which is I always access. And then what I'm going to do is I open the brackets here, then I move this first one, then I add the second one, like that. There are 6, remember. I add the second one, then I also add the third one, which is B3. If you have been following, then you know how I have B3, because it is by coding, just the statements. Then I have B4, and then I also add B5, and then I also add B6. What I want to do is now to divide this by 6 to get the average mean, and after I've closed the bracket, now I have divided by 6 to actually come up with the average. So it's going to bring me an output and shows that it has been executed. So if I go back to my main data set and I go to variable view, I'll find that I have a new variable, which is the average of the variables. I'm not going to do for all the variables, so I'm going to do the next one, which is for performance, because we are looking at tax assessment affecting performance. So quickly, let me also compute for performance. If I go to computation, and then I now I want performance. Then I'll just do performance. Performance. Then this was the previous one. Now performance, as usual, I have to open my brackets, and then performance is our last one. It is actually E1 plus E2 plus E3 plus E4 plus E5 plus E6 plus E7. Then I'm going to divide this by 7. Sorry, it is 7, to come up with the average. So once I divide by that, it also shows that it has been executed. Now if I go back to my data set, I also find that now I have performance. Now if I want to run a correlation quickly, to find out the relationship between, and also then accept or reject my hypothesis, then I would go to correlation, and then I go to bivariate, and then I can get these variables. They are at the end, and I will do this, and I also select the next, and then I can say I want Pearson correlation, yes, and then I can say okay. When I say okay, it should bring me the correlation, Pearson correlation, and this is where I can see whether the it should be significant at a level of 0.01, and this is 0.005, which shows that there is a significant effect or relationship between tax assessment and performance. If I want to do a regression, it would go through the same procedure. I have to analyze and go to regression and possibly do a linear regression, and then I can still select this variable as this is the dependent, and then the dependent is performance, and then the independent is assessment. Remember, it is one of the constructs of tax administration which affects performance. So, and then I would say okay. If I had computed the variables for other constructs, that is tax collection and tax enforcement, then I would have a table and of how each of those contributes to tax to performance of SMEs. For now, I will stop here, and then I'll be back with details again on how all these are interpreted and how you can actually analyze inferential statistics easily.